So my plan is to go through the media lessons and then just reference some things in the media lesson packets. They also have videos if you want to look at them and get an idea and talk about what virtual manipulatives might be useful. So notice the first one is use base 10 blocks to represent a number, and we already have a virtual manipulative for this. So let's look at that real quick. As you can see, this is not the first video I made. I didn't like my first one. Okay, so here they're given a number value and they represent it with the blocks. And then they write how many flats, rods, and units that this number is represented with or by. So in addition to having this direction, it might be nice if we had a direction where they're given the blocks and they need to fill in the flats, rods, units, and give the number. So I'm going to try to keep a list as I go. So 1, given a block representation, enter number of blocks of each type, and determine base 10 number. So basically just the reverse representation of what we gave them in this in the base box we have. We also talked about, so this wasn't too tedious with the number 140, dragging 1 and then dragging 4 of these. But something that might be nice, and I think you said you worked on this, Bill, is if they could double click this and have it end up in this area. We also might want this area to be a little bit bigger if it can extend to here. Again, you can see all of them here, but it would be nice if, if we, I just tried to double click it. You could see if we had something like this, it would take up and they wouldn't be able to see all of the blocks. Okay, let's look at the next one. So also something to mention that you probably already noticed. In this first type of problem, we're using the place value system specifically where we don't have 10 of any, we have less than 10 of any place value number. And this is going to contrast a little bit to the next types where we have decomposing and regrouping numbers. So here we have them represent the picture as base 10 blocks, where we wouldn't have more than 9 of any specific type of base 10 unit, and then we have them make a decomposition. So the idea with the decomposition is we want them to see that there are equivalent ways of writing this number with base 10 blocks. This is the simplest way in the number form. You can imagine that the decomposition is going to come in handy when we do subtraction, but again, we also want them to understand this idea of equivalency, that there's more than one way to do this and that our way is the simplest. So let's see what we might want to do here. Okay, and again, I think of the two types, one where they're given a number, and let me just reset this. One where they're given a number and they represent it, and another situation where they're given a picture and then they decompose it or regroup it. So yeah, I think now that I think about it, I think the regrouping one would be better for that. So let's just start with decomposing. So for decomposing, instead of I like the idea, even though it does it differently in the media lesson packet, I like the idea of giving them some amount of flats, rods, and units and having them decompose it like we have in the NLVM site. So say we tell them, I don't know, you have 111 and again, starting here it would be nice if we had the columns for the different place values. Okay, so they could distinguish between place value. So maybe we give them a picture of this, they drag this to a new place value, and they write that 1 flat, so we'd want them, so given a base block representation have them drag and decompose at least one unit, or at least one base block, into a new base block. Okay, and I'm kind of thinking as I'm writing this. So here, what I'm thinking is you give them the original base block representation, and maybe, so for this one, you give them this and they say that it's 1 flat, 1 rod, and 1 unit. And then maybe they write the number in place value form as 111. Then have them do the second part where they drag and decompose something. So kind of like with the chips, write this in at least 2 ways possibly. And then they'll write, so here for example, maybe they drag this. Now we could say that this is 11 tens and 1 1. So we'd say 0 flats, 11 rods, and 1 unit is another way to represent this, the original number. Okay. And again, I'm flexible on this. Again, I'm thinking out loud. So for regrouping, okay, so this is what we had for decomposing here. We have them make the original picture. It's also nice to connect this to hundreds, tens, and ones, but we don't necessarily have to yet. And then we have them decompose something and write it in a new way. And then regrouping is the other direction. You give them a value, hundreds, tens, ones, or flats, rods, units, whatever it's going to be, and have them regroup something. So write the original, or maybe here they're given the picture as base 10 blocks. So here's what I'm thinking. So maybe you give them this. Again, I really like the place value columns. Okay, and then they have to regroup. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, there's exactly 10. They have to regroup and carry over to the correct new place value. And then here there's 10. And carry that to the place value. Okay, so making sure here it gives them the number. We could do that, we could not do that. I don't really care. But the idea that if there's more than 10 of any one type of block, they're regrouping and putting it in a new place value column. Okay, so that will be 3. Given BB will be base blocks. Have them regroup 10 into a new larger place value. Okay. So that's the first three I see with this. I'm going to stop this video now, and then we'll start with a new idea.